So this video lesson is the first in a series, two parts for this initial part of solving equations. Now we're going to solve some basic equations here, and this lesson is just those using addition and subtraction. But before we get to actually solving equations, we need to do a quick review of some important vocabulary related to equations, starting with what an equation is. An equation is just what you get when you take two expressions and you set them equal to each other. Now, we have to be careful a little bit. An expression such as 17 and 20, we can't really set equal to each other because 17 is not the same as 20. Instead, more often what we see is expressions set equal to each other involving variables. Things like x plus 17 equals 12, 3x plus 1 equals 16, 3x equals 21. Now, remembering that a variable is just a letter used to stand into a number, we can choose a value for the variable that makes sense. There is one value for x, let's say in the case of the one now boxed in purple on the far right, 3x equals 21. There is only one value for x that makes this equation true, so that 3x really is equal to 21. In this case, you may have thought to yourself, well, what times 3 is equal to 21? 7. The only value of x that makes sense in this particular equation is x equals 7. And so what we call this is the solution to an equation. And specifically, a solution to an equation is the specific value of the variable that makes the equation true. We can't just substitute just any old value for the variable into any of these equations and get a true statement. For example, in the first equation, x plus 17 equals 12, we can't substitute x equals 0, because if we do, we get 17 equals 12, and it's not true. So there's a specific solution. And when you manipulate an equation to find the solution, you're doing what's called solving the equation. Now, I want you to take a second and pause the video and see, based on some mental math that you know, if you can figure out what the solution to these equations are. What value can we substitute in for the variable in x plus 17 equals 12, 3x plus 1 equals 16, and we'll throw out 3x equals 21 because we already looked at it. But for these two equations, see if you can think to yourself, what values does this variable have to have in order to make these equations true? Well, you should think to yourself in the first one, what plus 17 equals 12? Now, in this case, x has to be less than 0, because if x were 0, x plus 17 would be 17. And you can go through it a little bit, do maybe some guess and check. You'll find that x is equal to negative 5. When x is negative 5 plus 17 equals 12. There are no other values for this variable that make this equation true. And for the second one here, 3x plus 1 equals 16, immediately start to think, well, if 3x plus 1 is 16, that means this 3x probably has to equal 15. And if that's true, then x has to equal 5. No other value for this x will make 3x plus 1 equal to 16. X must equal 5. So each of these equations has exactly one solution. That won't always be true, but for the ones that we're talking about, it will be. So let's take a look at this similar but different equation, x plus 12 equals 17. Now we're going to break down how we can think about doing this with some important concepts from solving equations before I set you off to solve equations on your own. First, pause the video for a second if you want to, otherwise I'll give you about 5 to 10 seconds here of silence. Think about, what do you need to add to 12 to get to 17? Well, you should have come up with the idea that the only number you can add to 12 to get to 17 is 5. So the eventual solution of this equation is going to be 5, and we can see that through mental math. But we want to know a specific way of solving any equation involving addition or subtraction. Now, it may seem simple at this point, but trust me, you'll be thankful for practicing it when you get to more complicated equations. So the important thing about an equation is this equal sign. Those two sides of the equal sign have to always be equal. So if we do something to one side, we've upset the balance of the equation. And that is one of the most important parts of an equation, is that you must always keep that equation in balance. If we say that x plus 12 is equal to 17, we must keep that equation in balance. And so take a second to think about, what if we add or subtract something from one side of the equation? And we can add and subtract anything we want as long as we balance the equation. How do we balance this equation? If we say add 5 to x plus 12, what would we have to do to the 17? Well, to balance an equation on from something we've done on one side, we just have to do the exact same thing to the other. So if, for example, we added 15 to one side of the equation, we would have to make sure that we add 15 to the other side as well. Otherwise, we've upset the balance. Because if one value is equal to another, you can add 15 to both values and it will be the same. Similarly, we could take 12 away from both sides of the equation, as long as we do that to both sides. It keeps the equation in balance. It keeps the scales equal. And what that is technically called is the addition, or if you're subtracting, subtraction property of inequality. That is, adding or subtracting the same amount from both sides of an equation will produce what's called an equivalent equation, one with the same solution. And in short, what that means is, when we're working with an equation, we can add or subtract anything we want from one side as long as we do the exact same thing to the other side. So let's see that with the equation x plus 12 equals 17 and figure out how we can solve this rigorously. X plus 12 equals 17. Now, the red line here represents the equal sign, and the red line is going to act a bit like that balance and also a bit like a mirror. If you think about a mirror, if you put something in front of the mirror, you now see it in the mirror reflection itself. So the idea of a mirror reminds us that whatever we do to one side of the equation, we must do to the other side. So I've replaced the x with a mystery box so that we can keep the idea of we don't know what x is right now. We've added 12 to it, and what we've gotten is 17. The idea behind solving these equations is that we want to do what's called isolating the variable. That is, we want to leave the variable alone on one side. That way, we know exactly what that variable is. So if we look at the idea of isolating the variable on the left-hand side, we see that we have our variable x, but we've also added 12 to it. Now think to yourself, what can we do to undo this adding 12? We've added 12 to a number. If we want to undo the adding of 12, we have to take that 12 back. So we have to subtract. And because we've subtracted on the left-hand side, we must subtract on the right-hand side because that keeps the equation in balance. Always, 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 we must keep the equation in balance. Whatever we do to one side, we must do to the other side. Now, on the right-hand side, we have 17 minus 12. But on the left-hand side, we have a positive 12 minus 12. If we take 12 minus 12, that gives us a 0, which is more or less nothing. In fact, it exactly is nothing when we add or subtract. So the 12s on the left-hand side of the equation disappear. What we're left with is just the box and whatever 17 minus 12 is. 17 minus 12 is 5. As we said before, we knew that 5 plus 12 was equal to 17, and now, by adding or subtracting something to both sides of the equation, we have found that our mystery box x really is equal to 5. Now try that on this subtraction problem here. Pause the video and see what you can do. X minus 12 is equal to negative 5. What are you going to have to do to decide what number x we can take 12 away from, and get negative 5? We can think about this as just what number it is, or we can do what we learned before, which is add or subtract something to both sides of the equation. Remember, this equation must stay balanced. If it happens to one side, it must happen to the other. Well, right here on the left-hand side, we have a minus 12. We are taking 12 away from x. If we want to undo that taking 12 away from x, getting rid of that subtracting 12, we need to do the opposite. We need to add 12. But because we've added 12 to one side, we must add 12 to the other side also. Now x minus 12 plus 12, because negative 12 and because subtracting 12 and adding 12 are opposite operations, called inverse operations, we're left with x plus 0. 12 and minus 12 cancel each other out. This side of the equation just has an x. On the other side, we have negative 5 plus 12. Now, remembering our rules for adding and subtracting negative integers, 12 minus 5 is 7. 12 is bigger, so we are left with a 7. And we found out rigorously that 7 is the only number that we can take 12 away from to get negative 5. So using this idea, you must add or subtract the same value from each side as we did here. X plus 12 equals 17. We had a plus 12. We used a minus 12 to cancel it out. But because we subtracted 12 on one side, we had to subtract 12 on the other side of the mirror, on the other side of the scale. See what you can do with these four equations here. X plus negative 5 equals negative 5, x plus 15 equals negative 4, x minus 12 equals 16, and x minus 9 equals negative 5. Remember, whatever you do to one side of the equation, you must do to the other side of the equation, and you're looking to get rid of everything on the same side as x. Starting with number 1, we are adding a negative 5 to the left-hand side, so in order to undo that, we need to subtract a negative 5 from the left-hand side, which means we subtract a negative 5 from the right-hand side. Remembering that subtracting a negative is the same as adding a positive. For the left-hand side, we already know that plus negative 5 minus negative 5 is going to be 0. Our x is left alone, happy to look in the mirror and see what he's equal to. Negative 5 plus 5 is 0. And so, in this case, x is equal to 0. For number 2, x minus 12 is equal to 16. We are subtracting 12 from x. That means in order to figure out what x is, we have to undo that subtraction. We have a value, we take 12 away, we get 16. How do we find that value? We add that 12 back in. So we're going to add 12 to both sides because adding 12 is the inverse operation of subtracting 12. Well, x minus 12 plus 12, these two values, complete opposites, cancel each other out. The x is left by itself on that side. 16 plus 12 is 28. So the solution to this equation is x equals 28. For number 3, x plus 15 equals negative 4. We are adding 15, so we need to do the opposite, which is subtracting 15. Again, subtracting 15 from both sides. X plus 15 minus 15, the 15's cancel, x is equal to something. Negative 4 minus 15, which is negative 4 plus a negative 15, is negative 19. And finally, x minus 9 is equal to negative 5. We have x minus 9, so we add 9 to both sides to get rid of it. Again, must do it to both sides. X minus 9 plus 9 leaves just x, and negative 5 plus 9 is 4. So hopefully when you went through these equations, you didn't just look at it and say, I know what x is. You went through this rigorous process of adding or subtracting the same thing from both sides. This is very important because this is the basic process which is used to solve any equation you will find at any point, almost any point, going up through the next several years of math. So one more time, to solve an equation that just has an addition or subtraction in it, all we do is we do the opposite of what is done with that equation. And we can do that as long as we add or subtract from both sides of the equation. An equation is like a scale. It must remain in balance. So whatever you do to one side, you must do to the other side also. Because if you add 5 to one side, all of a sudden the scale is off balance. So we add 5 to that side, and we bring it back.